Hi guys, our lesson today is on finding limits of trig functions. We're going to find them graphically. First of all, let's look at limit notation. You see written right here, this LIM means limit. It's read basically as the limit of f of x as x approaches a. So that's what you will see when you're working with limits. This is what is basically giving you directions on what to do, what function to use, and what x value to head towards. So the answer, this is really important for you to remember, the answer to a limit is the y value of the function at a. Okay, if you can remember that, we're pretty good to go. The answer to a limit is the y value of the function at a. So the limit as x approaches a of f of x equals f of a. We have a full limit, which is what you're looking at here. This first thing we looked at is a full limit. The limit as approaches a. And we also have one-sided limits. We have a right-hand limit. You'll notice here on this right here, notice that little plus? That means it's a right-hand limit. It's approaching from the right. We're headed from the right to whatever x value. A left-handed limit, if we look at that notation, see the little negative right there? That is a left-handed limit and means we're approaching from the left. We're headed towards a from the left. In order for a limit to exist, the right-hand limit and the left-hand limit must be equal. This is like a theorem. Okay, in order for the limit to exist, the right-hand limit and the left-hand limit must be equal. We're just going to work on one technique today, and that is using graphing to solve limits. So we're going to look at the graph, and we're going to decide what the answer to our limit problem is. Alright, so let's take a look at our first couple of examples. The first one wants us to look at sine, the limit of sine x as x approaches pi from the left. So the first thing that we're going to do is we're going to draw a graph of sine. We really only care about the part that's around pi. So we're going to have to remember how to draw the graph of sine. If you remember, we start at 0, 0, go like that. This happens to be pi. So looking at it, the y value of the function at pi is 0. Now, as we're headed from the left, so that means that I'm coming, let's change color real quick. That means that I'm coming from the left. I'm following the function, headed from the left, until I hit pi. Notice the y value of where I am when I hit pi is 0. That means that the answer to this, the answer to the limit is 0. That's the y value that we are approaching when we're approaching the x value of pi from the left. So that's that one. Alright, so let's take a look at our next one. The next one asks us to do the limit of 2 secant x as x approaches pi over 2. Now notice it's not a one-sided limit, it's just pi over 2. We're going to approach pi over 2. The first thing that we have to remember how to do is to, the graph of 2 secant x. Alright, so let's take a look at that. Secant is the reciprocal of cosine. So we're looking at a cosine graph. The 2 means it's stretched up, basically instead of the amplitude, well, it's not really an amplitude. Instead of starting at 1, it's going to start at 2 and negative 2. And let's remind ourselves, let's draw the cosine graph. Remember how we can dot that in. And then the secant graph is going to look like that. We'll have an asymptote here and here. That's just a little quick sketch. You just need a sketch to do these. It doesn't have to be perfect. But we do need to know what our x values are, and we basically, this is 0, And then we have pi over 2, it's right here, and then pi, 3 pi over 2, and then 2 pi. Okay. We are really only interested at pi over 2. So let's take a look at pi over 2. Notice how, let's change color. Notice how as I'm coming from the left, I'm headed, so here's my goal. My goal is pi over 2. That's where I'm headed to. I'm coming from the left and I have to be on the road. Okay, I have to be on the function. I can't be over here, you know, four-wheeling. There's no off-road stuff in limits. You have to be on the function. I get on the function and I head towards pi over 2. Notice that I'm going to infinity. So we're going to do the one-sided limits. So we're going to do the limit as x goes to pi over 2 from the left of 2 secant x. Well, we just saw that. That is going to be infinity. Alright, let's come from the other way. Okay, let's go from the other way. So the limit as x goes to pi over 2 from the right of 2 secant x. Let's see what's happening over here. So my goal is still pi over 2. I get on the function as close as I can to pi over 2. Maybe right here. And I head towards pi over 2. In this case, I'm headed to negative infinity. So this equals negative infinity. Notice how my two sides don't equal. I'm going to positive infinity and negative infinity. And if we remember up here, for a limit to exist, the right hand and the left hand have to equal each other. Well, negative infinity and positive infinity aren't the same thing. They're really not numbers anyway. We'll get into that later. But since they're not approaching the same place, we will say D in E does not exist. So that's our answer to number 2. Okay, hopefully we're doing pretty good. Let's keep going and look at our next two examples. Number 3, we have cosine 2x. Alright, so again, we want the limit as x goes to 0 of cosine 2x. So let's remember what the 2 does. Well, the 2 is going to change the period. If you remember that, it changes the period. It actually shrinks the period. It looks like it should be multiplied by 2, but we hopefully remember from our trig graphing that it's actually shrunk in half. So instead of a period of 0 to 2 pi, we're going to have a period just from 0 to pi. Now in this particular case, we're headed to 0. Alright, so let's draw that. We really only care about the 0. We don't have our y values are the same. It's just the x values that have been changed. So when it goes like this, this is actually ends in pi instead of 2 pi, and that's actually pi over 2, and then 0 of course is here. So we'll go back like that. Alright, so we're headed towards 0. Doesn't really matter. I mean, we can look at both sides. It's kind of fun. We'll go from the left. We're headed to, where are we headed? We are headed to 1, looks like to me. That's a y value of 1. Coming from the right, yep, we're headed to 1. So 1 is our answer. That's where we're headed. That's our answer. We get there from both sides. So since we left-sided limit equals 1, the right-sided limit equals 1, our full limit equals 1. Alright, fantastic. Let's do number 4. It's getting more and more fun, isn't it? Okay, number 4. We have the limit as x approaches pi. Looks like pi from the right of cosecant of x plus pi. Okay, so let's remember what that is. Cosecant of x plus pi. That's a phase shift, the x plus pi. We just have a phase shift there. So let's draw our graph. Cosecant is the reciprocal of sine. Okay, and we have a phase shift, so we're not going to start sine at 0 like it normally starts, we're going to move left pi to start it. Left pi. Okay, cosecant sine. So here's pi, and our period hasn't changed, so we still have a period of 2 pi. I'm going to start at negative pi and go to pi. And I'm going to do my dotted line thing. So this is secant, this is sine. So we are going to go up like that, and down, and up. So my asymptotes are going to be here, and here, and here. And boy, it's a crazy looking graph. Okay, there is my cosecant. So we're going to pi, which is over here. Alright, we're going to have this up here too. Now look, I mean, we can look at this and see that we're not headed there the same way. So I'm going to pi. Coming from the right, I'm going to infinity. Coming from the left, I'm going to negative infinity. So what do we say when it happens? So coming from the right is positive infinity, left is negative infinity. Our answer is D and E. But here's the key. When you have a D and E answer, which with trig functions happens sometimes, but it's kind of rare actually. When you have a D and E answer, you've got to show the limit from both sides. You can't just say, oh, it's D and E. It's not going to work. So actually, this one's not even that bad. This one, really little, I can hardly see it. I think that says pi from the right. So we really only care about the right. We don't care about the full thing. The full thing is D and E, but it's not asking us for the full thing. It's asking us from the right. So if we just pay attention to the right, it just says coming from the right, it is going to be infinity. Okay, that's a little bit less work. Cool. Hopefully we're doing okay. Let's go, we have 2 more to do. So 5 and 6. 2 more fun graphs to graph. Okay, number 5 is tangent pi x plus 1. The limit of tangent pi x plus 1 as x goes to 0. Alright. This one, the period is pretty well messed up, and so is, it's also shifted up 1. So that's kind of crazy. Let's see what happens. Our normal period is pi. If you remember our little formula, period equals normal period, which is pi over b. My b is pi, so period equals pi over pi, which is 1. So my period is 1. Alright. So instead of starting at negative pi over 2 and going to pi over 2, I'm actually going to start, my period is 1, I'm actually going to start at negative 1/2, and I'm going to go to 1/2. Alright, and I'm shifted up 1, so instead of going through 0, I'm going to go through 1. So it looks kind of like that. And we're headed to 1. Oh, sorry, we're headed to an x of 0. Alright, so headed to an x of 0. Let's investigate. Okay, I'm headed towards x of 0. I'm coming from the left. I'm headed to 1. Coming from the right, headed to 1. So my answer is 1. Fantastic. Alright, last one. 3 cotangent x. Okay, remember the 3 in front of the cotangent just means that it's stretched up. There's no kind of period shift or anything. So it's just regular. It starts at 0 and it goes to pi. Our limit is actually going to pi. So that's great. So we go like that, if you remember. Okay, there's my graph. Now let's look from the right and the left. So I'm headed to pi. Coming from the right, I'm headed to infinity. Coming from the left, I'm headed to negative infinity. So the limit as x goes to pi from the right of 3 cotangent x equals infinity. Limit x goes to pi from the left of 3 cotangent x equals negative infinity. Therefore, what do we know? Yes, you're right. It is d in e. The full limit is d in e, so that full limit is d in e. Fantastic. All right, that's the end of the lesson.